Hi, and welcome to another C++ programming tutorial from Someone9031. And in this tutorial, I'm going to be teaching you guys about deep copies and deep copy constructors in C++. So a few tutorials ago, I taught you guys all about copy constructors in C++, and I explained a bit about the difference between a shallow copy and a deep copy, but I never really told you guys how to create your own deep copy constructor to perform deep copies. So that's what I'll be doing today. Now, I've written myself a short little class here. It's got a constructor, copy constructor, deconstructor, and one variable. And so it's very simple. So first off, we're going to review what a shallow copy and a deep copy are. So a shallow copy means basically you perform a member-by-member copy, which means you take the value of every variable within your source object, the object that you're copying from, and you input that value into the corresponding variable within the destination object, which is the object that you are copying to. So all the values are copied. So it works perfectly fine for most circumstances. And if you don't provide a copy constructor, the C++ default copy constructor that it provides also performs a shallow copy. Now, the problem with that starts when you have dynamically allocated pointers and stuff. So that's where all the problems start. So if you look at my code here, we have a constructor, and within that constructor, this string pointer s, and yeah, I also know that we haven't covered strings yet, but I will do that soon. But you should just know for now that you basically use a string just like a character array, except you can input a string of as long as you want, and it will automatically size itself. So for now, that's all you need to know. I will be going over strings in a later tutorial. So we have a string pointer called s, and within the constructor, when the object is created, s is dynamically allocated, new string, and the value allocated is put into it. And when we get to the destructor, usually when we have dynamically allocated variables, the destructor deallocates them or deletes them, but for our circumstances today, we will not be deleting the pointer. We will simply be outputting the current state of s, the value that is currently within it. So if it's the first time the destructor has been called, then s will equal allocated. But if the destructor has already been called, s will equal deleted. So it prints out the state. And the copy constructor simply does a member-by-member copy. Now down here, this is where all of our action is happening, basically. This is our void my function. This is our function, and here we create a my class object called MC, and we create another one called copy, and then we use the copy constructor to copy the value of MC into it. And in our main function, the only thing that we do is call our my function function. So let's run our program and see what happens. So here you go. How this program works is when we call my function, these objects are created as local objects, and so that means when a function returned or ended, these objects were deleted. Their destructor was called. So the first call for the destructor was for the object MC, and when it printed out the state, it printed out allocated because that was what it still was. Then s was set to deleted. Now the second time the destructor was called, it was called for copy. Now for copy, it has printed out deleted. So that means the destructor has already been called on that particular pointer s. So basically what happened here is when you do a member-by-member copy with pointers, basically when you copy a pointer into another pointer, you do this. You're copying the address of whatever that pointer points to and copying the address into the other one. So now both of these pointers point to the same memory area on the heap that you dynamically allocated. And when you delete or deallocate any one of these two copies of each other, they both point to the same memory area. So when one is deleted, that memory area is put back. But the second one, whichever one has not been deleted yet, still points to that same memory area. So that is not good. It can still access it and all that stuff. So yeah, that's not what we want. And so to counter that, we use something known as a deep copy. And basically, a deep copy is just something that is not a shallow copy. It means basically you reallocate memory, basically like this. So s equals new string, and then dereference s equals dereference mc.s. So this would be how you do a deep copy of this. So if we run it again, we shall find that both say allocated. So that is very good. Basically, what you have to do to make a deep copy is allocate new memory and then input the value of the source pointer, the value stored within the source pointer, and input the value into your destination. Not just doing s equals mc.s, because that copies the address, and that is not what we want. So yeah, that is the end of this tutorial. If you like this video, please subscribe, rate, and if you have any feedback, questions, or comments, please feel free to leave a comment in the comment section, or you can message me on YouTube. Thanks for watching.